Hi guys, welcome to our first lesson 4.01, and this is about parallel lines and transversals. Before we get started today, let's take a look at this warm-up. We're talking about ray AB bisects angle CAD. The definition of bisects means to cut into two equal pieces, bi meaning two. So I know this angle CAB is congruent to angle BAD, and I've marked them as congruent. Go ahead and set up your algebraic equation and solve for the value of x. Pause the video and come back and check your work. Hopefully you did well with this. My particular method is that I like to clear my fraction first, so I multiplied the entire equation by 2 just to clear the fraction. You may have solved it a different way. That's fine. Okay, before we get started with parallel lines and transversals, let's talk about a couple of our old vocabulary terms like vertical angles, and we know that vertical angles are always congruent. Angle AOC is congruent to angle BOD. You do have to use all three letters. You can't just say angle O, because there's 1, 2, 3, 4 angles that have angle O. We also know that angle AOB is congruent to angle COD. They are vertical angles. They share a vertex, and they are non-adjacent. They do not share a side. Also remember our linear pair postulate, LPP. If two angles form a linear pair, then their sum is 180 degrees. Angles 5 and 6 are a linear pair. They are adjacent and on the same line. They share this ray right here that makes them adjacent, share the same line, the red one. So they're a linear pair, which means they are supplementary. Definition of supplementary is that the measures add up to 180 degrees. So when you get problems like this, you need to first think about what is the relationship between these two angles. For A, it's a linear pair, and I know that that means they're supplementary. For B, I know these two angles are vertical angles, and so I know that they are congruent. This helps you set up your algebraic equations to solve. So go ahead and try to set up your algebraic equations for A and B, solve for x, pause the video, come back and check your work. Hopefully you set these up to equal 180, and you would set these two equal to each other. Okay, today we're going to get into parallel lines and transversals. So let's talk about parallel lines. Parallel lines, the definition is of two lines that are in the same plane that do not intersect. They are in the same plane, meaning geometric plane, slice of space. Notation is L is parallel to M. And how would you show that parallel lines are matching in a picture? You would put on matching arrows. Matching arrows. So I added these in, so I don't even need the notation at this point. Just from the notation here, I know that line L is parallel to line M with the matching arrowheads. Okay, another term is transversal. I want you to think about the prefix trans, like transatlantic flight would mean to cross the Atlantic Ocean, or transpacific flight would be to cross the Pacific Ocean. So a transversal in a plane, not an airplane, a geometric plane, is a line is a transversal if and only if it intersects two or more lines. Now here L is not parallel to M, but line T is a transversal because it crosses both line L and M. Whenever you have lines in a transversal, it's going to create special angles because every intersection will have 4 angles. Here the interior angles are going to be the ones inside the two lines being crossed. So angles 4, 5, 3, and 6. We call those interior angles. The ones outside of the two lines that are being crossed are our exterior angles. Okay, two angles on the same side of the transversal and on corresponding sides of the other two lines. So for instance, this one's on the top and this one's on the top. Those are corresponding angles. You have several corresponding angles. 3 is on the left side of the transversal and on the bottom of the line. 7 is on the left side of the transversal on the bottom of the line. 2 is on the right side of the transversal and on the top of the line. 6 is on the right side of the transversal on the top of the line. And finally, 4 is on the right side, bottom of the line, and 8 is on the right side, bottom of the line. Those are all corresponding angles. So they have the same relative positions in geometric figures. Think about them as intersection points. Like if I cut out that intersection, I cut out that intersection. You know, this one and this one are in the same little quadrant. That makes them corresponding. Now we have a corresponding angle postulate. It says if two parallel lines, remember you don't have to be parallel to have a transversal, but if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So using this postulate, name a pair of congruent angles. Okay, well, angle 2 is in the same position as angle 6. Everybody see that? They're both on top of the lines and on the right hand side of the transversal. What would be the transformation that would map 2 to 6 is a translation. And we know that a translation is an isometry, and it creates a congruent figure. So I could just slide 2 down to 6, or I could slide 6 up to 1. So angle 2 is congruent to angle 6. Now think about this, guys. We also have angle 7 right here that is vertical to angle 6. So I want you to be thinking about that. Okay, we also have something called alternate interior angles. Notice these are not parallel lines, we're just talking about positioning. So my alternate interior angles, they're going to be on alternate sides of the transversal, but inside the two lines. So 4 and 6 are on opposite sides of the transversals, but inside the two lines. And then I've got 3 and 5 that are alternate interior angles as well. Just talking about their position. I also have alternate exterior angles. Now I'm going to still be on opposite sides of the transversal, but I'm outside of the lines. See how the alternate exterior is really just a description. I'm on alternate sides of the transversal, and I'm exterior of the two lines being crossed by the transversal. We do have an alternate interior angle theorem that says that if two parallel lines are crossed by a transversal, then the alternate interior angles are congruent. So angle 1 and angle 3 are on alternate sides of the transversal inside the two parallel lines. What rigid transformation would map angle 1 to angle 3? It would just be a rotation. A rotation is an isometry or a rigid transformation, and that would create a congruent angle. Okay, so now again, I talked about this one. Let's take a look. Angle 2 is congruent to angle 3, and that is because of vertical angles. Well, I know that angle 1 is congruent to angle 3 because of alternate interior angles theorem. What does that mean? I've got two different things congruent to the same thing. That means that angle 2 is also congruent to angle 1. And this is your transitive TIVE property of congruency. That's very important with these types of problems. Okay, my alternate exterior angle says if two parallel lines are cut by a transversal, then the alternate exterior, so outside, opposite sides of their alternate exterior angles are congruent. I have parallel lines cut by a transversal. What rigid transformation would map angle 4 onto angle 2? Again, a rotation. Now notice 1 and 4 are vertical, so that makes them congruent. 2 and 3 are vertical, that makes them congruent. So all these angles are actually congruent. Okay, another piece of vocabulary, same side interior. Exactly what it sounds like. We're on the same side of the transversal inside the parallel lines. So those are my same side interior angles, 3 and 6, 2 and 4. Same side exterior angles, I've got 1 and 8. They're on the same side and they are exterior. And I've got 2 and 7. Now our same side interior angle theorem says if two parallel lines are cut by the transversal, then the same side are supplementary. There is no rigid transformation, not a rigid one. You would have to have a dilation. They are not congruent. And how do we know angle 1 and angle 2 are supplementary? Well, angle 1 is congruent to angle 3, and angle 2 and 3 are a linear pair. So I could substitute angle 1 for angle 3, knowing that now angle 2 and 1 are supplementary. All right, guys, this is the end of the line. This is where you get to your homework. There's a key posted for you in the Google Doc. If you have any questions or concerns, hit me up. Basically, I want you to, let's just recall, if you have parallel lines and a transversal, let me just add a little. Parallel lines, I'm going to use notation, and a transversal, you have 1, 2, 3, 4, 5, 6, 7, 8 angles that are created. And we know that our alternate exterior are congruent. We know that our alternate interior are congruent. We know that our vertical angles are congruent. So our alternate exterior, our alternate interior, and our verticals are all congruent. Anything else is supplementary. Same side interior or exterior are supplementary, and your linear pairs are supplementary. Everything else is congruent, just to finish it up. So when you start your homework, I want you to write the angle relationship. Like this one would be alternate interior. And I want you to let me know that you know that means it's congruent. So write the name and what the name means. All right, guys, if you have any questions or concerns, again, just hit me up, and I hope you have a great day.